Today, I'm going to show you how to automate the whole movie night experience. Let's press on this smart switch from Zeus 3 times down to start. You can program this Zeus switch to control multiple devices in the house as seen in this video. In the old days, I had to dim the lights, start the projector, start the media player, lower the projector screen, wait for the screen to come down, and hit the stop button on the remote. Otherwise, it'll hit my radiator right there. But as you can see, all I had to do was press on the light switch and we're all set. Once I'm done watching, tapping 3 times up will revert the room back to normal as before. In this video, we'll focus on making the motorized projector screen smart and working in conjunction with Home Assistant Hub. We'll need to solder some stuff as well. By the way, if you're going to buy a screen, make sure you get anything with tab tension. What does that mean? It means the screen are stretched tight as seen here on the sides as well as the top and bottom, thereby eliminating any wrinkles. Otherwise, you'll see ripples on the screen, and that's kind of annoying. And even on my tab tension screen, there were ripples, and that's just because the screen has been released. The ripples will go away over time. This screen comes with the remote that's power inline. I have hidden that part in the adjacent closet. Otherwise, it'll dangle hideously in this room. This is my setup to make the screen smart. I'm sure there is an elegant way to do it, but this method is guaranteed to work with any brand and any configuration. In the future, I'll do another video specific to the screen setup so you can see the cleaner solution. But honestly, this whole thing will be hidden, so that's not really a big deal on how ugly this existing setup is. Let's focus first on the remote control right here. Take the whole thing apart since we just want the bare circuit board. Remove the battery cover right here. Take out the 2 tiny screws right there. Use a small ice picker to separate the top half away from the bottom half. These are 3 momentary switches to control right here, stop, and down. So we'll use 3 relays to simulate the button presses. By the way, you can use this trick to simulate button presses for any devices in your house, whether it's the AC unit, the air conditioner, the fan, the kitchen hood vents, whatever. For each button, we're going to solder in 2 wires. You have to solder in these pins, by the way, the bottom and the top right here. So you can either solder the 2 wires in from the left-hand side or from the right-hand side, and that's what I did with the right-hand side. 2 solders per button. So for the up button, 1 wire starts from here, right there, to the ground on the relay, which is labeled COM. The green wire will start from here and all the way over to this relay into the NO, normally open pin. On the other side of the relay, pin VCC goes to 5 volts, ground to ground, and data goes to D5. It looks really confusing in this picture, so that's why I made this wiring diagram for you to easily follow. Repeat the same thing for the remaining 2 buttons. We'll use D6 for the data pin of the stop button relay and D7 for the data pin of the up button relay. I'm going to share this wiring diagram with you in the link below. My actual wiring does not match 100% as seen in the picture, and that's just because the wiring software has different orientations. But for sure, the labels are exactly the same. So for example, the software shows NO as being on the left-hand side, but in reality, the NO pin right here is on the right-hand side. This remote right here uses 12 volts. For our power source, we'll use the 12 volt DC power plug as seen here. Unfortunately, the D1 mini chip we'll use requires 5 volts. That's not a big deal. We'll use this little buck converter to change 12 volts to 5 volts. So that's why you're seeing this buck converter tap into the 12-volt rail and the ground rail. You'll need a multimeter and adjust this little knob right here with a small, tiny flathead screwdriver. With the multimeter in DC voltage mode, place the two probes right here on the right-hand side as well as on the left-hand side to verify you are indeed getting 5 to 5.2 volts. Once you do, go ahead and feed the positive and the negative into the 5-volt side of the rail, and then feed that into the 5 volts and the ground of the D1 Mini. Meanwhile, on this side, the 12 volts feeds into the positive side of the remote. The ground goes into the negative side of the remote. And that concludes all of the hardware side. Let's take a closer look at the software side. We're going to be using ESPHome to get it into Home Assistant. I'm going to assume you know the basics. If not, please take a look at this video for an in-depth look on setting up the chip from start to finish. I'm going to share this whole code with you as well. So the top section, this part right here from line 1 to 16 is really basic generic stuff. The main code is this section right here from line 18 to 77. So here are our switches that we route to the D5, the D6, and the D7 pin. Might as well label them accordingly so that you don't get yourself confused later on. So it's up, stop, and down. This cover section right here is almost identical to the roller shades that we did earlier in another video. Because think about it, it's basically treating this screen as a roller shade, right? Whether it's going down or up. Open up the shade or close down the shade. To make the relay act as a momentary switch, we're going to hit it on and then delay for 2 seconds and then turn it off instantly. Then it will take about 20 seconds to open up the whole thing or raise the screen all the way up, and that takes 20 seconds. Your results may vary, so you have to play around with this timing right here. This close action is the complete opposite, meaning how long it will take from the projector screen to be fully retracted to when it goes all the way down. And for me, that takes 18 seconds. Again, play around with the numbers for your setup. In Home Assistant, this is what it looks like on my ESPHome tab. Let's go over to the projector and click on Edit. I got all of the code ready. The way that I personally like it is click on the Install button right here, Manual Download, and click on Modern Formats. It's going to give me a bin file. Once you get the bin file, plug the D1 Mini into the USB ports. Open up Internet Explorer. It has to be Internet Explorer or Chrome. Open up this website right here, web.esphome.io. Click on Connect. Scroll around somewhere to find this USB serial and then click on Connect. Click on Install. Choose File. Choose the bin file that you compiled earlier from the download folder or wherever you saved the bin file, and then click on Install. Again, this whole process of flashing the bin onto the chip was thoroughly covered in the previous video. Now, to add this ESPHome device into Home Assistant, let's go into the Settings, Integrations, Add Integration, search for ESPHome, and then type in the IP address of that D1 Mini. If you don't know what the IP address is, it's okay. You can just go into the ESPHome tab, go over to Logs, click on Wirelessly, and here you can see the IP address, which is, for me, 192.168.1.215. I'm going to click on Close because I don't need it. Enter in your IP address. Don't worry about the port number, and then click on Submit. If all is good, you can definitely see the device now in ESPHome section of the integration. So let's click on it. Let's click on 16 devices for me. Here we can see the projector screen. And now I can control the whole thing, whether it's manually or automatically. Pretty slick. Let's create the automation that you saw earlier in the video. We're going to go to Settings, Automation. I already created the automation, so this is what it looks like for me. The trigger will be the Zeus being tapped down 3 times. Here are all of the actions. You can see that the lights will dim down. It's going to turn on the Raspberry Pi 4 to watch movies. and of course lower the projector screen down. This is what it looks like in YAML code. So let's go to the three dots and go down to edit in YAML. The top section is the Zeus switch, and here are all of the actions that's associated with it. You got the lights dimmed down to 5%. You got the smart plug turning on, activating the Raspberry Pi 4. And you got the cover, which is the screen going down or close. Now to actually turn the projector on or off, please follow this video that was covered previously. First, you have to capture the IR command from the projector remote control, and then transmit it back to control the projector whether it's on or off. For simplicity's sake, it is not covered in this video, but you can certainly implement it yourself. Hopefully this video helps you on how to make your projector screen even better than before. I really appreciate you guys subscribing to my channel, liking this video, and thanks for watching.